Okay, this is a quick video which is going to cover section 11.5 on page 191 of the Statistics in Mechanics book, and it is basically deriving the Suvat equations from the definition of acceleration. We go to here. We're going to derive the five Suvat equations. The definition of acceleration is to say v equals the integral of a dt, when a is a function of time. Now, supposing a is a constant, so the Suvat equations, of course, are for constant acceleration only. So if a equals a constant, then we can integrate a. It's just v equals a t plus an arbitrary constant. Well, what should the arbitrary constant be? Well, if we know the velocity when t is 0, the initial velocity, so if the initial velocity is u, so initial velocity, that's the velocity when t is 0, we would have u equals 0 plus c. So c is u. So we have v equals u plus at, and that is the first of the Suvat equations. Now we can go further because we know the definition of velocity. It's the change in displacement. So we have v is the integral of wrong way round. S is the integral of v dt, because v is a change in displacement. And v we have as u plus at, so s is the integral of u plus at dt. U is a constant, a is a constant, so integrating we'll get ut, and then at is a constant times t, and if you integrate t you'll get a half t squared, so that would be a half at squared, which is the familiar formula, plus an arbitrary constant. Now what should that be? Well, displacement is the change in position, so the change in position from when we start, the t is 0, to the time t. So we would have when t equals 0, I should say, s equals 0. So s is 0, so 0 equals t is 0 plus c. So c is 0, and we have s is ut plus a half at squared. So we have the two key equations, and we can get the other three by substitution. If you substitute v into what should be a into of v equals u plus at. So if I write that as a is v minus u over t, and substituting it for s, then I will get, well, what would I get actually? S is u v minus u over t. Oh, wrong. S equals ut plus a half times v minus u over t squared, which is a. So s equals ut plus the t's, one t here cancels that one t there, so that's a half vt minus a half ut. So we get equals ut minus a half ut is a half ut. So we get a half u plus vt. So that's another one. If we eliminate t, so if we write t equals v minus u over a, and substitute that into s equals ut plus a half at squared. Oops. Ut plus a half at squared. Then we will get s is u v minus u over a plus a times v minus u over a squared. So it would be v minus u over squared over a squared, and of course we have the 2. So we can divide by a there and multiply by 2a. Multiply everything by 2a, I'll get 2as on this side equals, I'm going to multiply that by 2, 2uv minus 2u squared plus v squared minus 2uv plus u squared by squaring out that binomial. And we can see the 2uv cancels, and then we have v squared minus 2u squared plus 2u squared. So that is in fact equal v squared minus u squared, which gives us v squared equals u squared plus 2as. And there you have the all of the Suvat equations for constant acceleration only. You can only use them for constant acceleration, and they obviously are a special case of the definition of acceleration is the derivative, the change in velocity. Okay, there is a short exercise on that one. Exercise 11e on page 192.